Hello mga ka-Johnny! Welcome back to my YouTube channel. Again, this is Sir Robin Sanipulan, your partner in learning mathematics. Before you proceed in this video, do not forget to click the subscribe button and give me a thumbs up if my video helps you. Okay?
Okay, so welcome back to my video, ladies and gentlemen. Again, this is Sir Robin Sanipulan, your partner in learning mathematics. Okay, so in this video, we will be talking about the inverse of the function. Okay, so we will be learning how inverse function works. Okay, so inverse function, this is the typical function that we've learned before. But before we go deeper to the definition of the inverse function, let's have a review of the typical function that we used. Okay, so when we say function, ladies and gentlemen, if you still remember, function, that is a relationship of two variables, and these two variables are simply the variable x to y, or if we're going to associate this one as a function as a machine, this is a relationship of input, or in every input there is an output. Okay, if we are going to associate this one in a variable, so meaning this is a relationship of independent variable and dependent variable. If we are going to be more mathematical, we are referring to the relationship of domain and domain and range. Okay, so this is how we define the typical function, ladies and gentlemen, the relationship of these two mentioned variables. But now, how are we going to define function now, wherein we are going to consider the inverse function? Okay, so that is the goal of this video, identifying and defining the work of inverse function. Okay, you say, when you say inverse of the function, we are simply referring to the interchange of the roles of these variables. When I say interchange, the role of x before is the role of independent variable, meaning this will act now as our dependent variable. Also, the role of our y variable here is the original role is the role of dependent. This time, the role of y will serve as our independent variable. If the mindset before is x corresponds to y, in the inverse function, the mindset when it comes to inverse function is different. Okay, so this time it is the mindset of y corresponds to x. Okay, so that's how the inverse function works. Okay, again, the interchanging of position. Okay, so how are we going to identify, or how are we going to denote that we are referring to the inverse function? Okay, so this is how are we going to denote inverse of the function. Example, I have here the original function f of x. What is the notation, or how am I going to denote if I am referring to the inverse of this f of x? Simply, you are going to write f of x, you are going to write -1 as an exponent, and same f of x. Okay, so f -1 of x, that it means this is the inverse of f of x. So meaning you are going to put -1 to indicate that you are getting the inverse of the original function. Again, that's how are we going to denote or to represent the inverse function mathematically. Okay, so I do hope that the definition of the inverse is clear to you. I believe that from the word itself, inverse, okay, we are going to think in a reverse manner, ladies and gentlemen. Okay, so to understand it even more, let's have a different representation of the original function. And from that, we are going to get the inverse of this different representation, ladies and gentlemen. Okay, so now, here it goes. So we believe that in the original function, ladies and gentlemen, we have different representation of this function, ladies and gentlemen. Okay, so first is the table of values, second is mapping, third is the set of ordered pairs, and the fourth one is graphing. Okay, so from these four different representation of function, I'm gonna help you find the inverse of it by just a mere inspection. Okay, just a blink of your eye, we will be able to find the inverse of this different representation of function. Okay, so without further ado, let's begin with the table of values. Okay, so from in the table of values, we have here x and f of x. So I have here all of my domains 1, 3, 5, and 7, and I have here my f of x as 2, 4, 6, and 8. So how are we going to find the inverse of this table of values? Since earlier we defined this one as an exchange of roles. Okay, so what are we going to do right now is let's create. Okay, let's create another table of values that will really define the inverse of this original table of values. Okay, so let's create now a table of values. So I have here my x, and again I have to put -1, indicating that this is now the inverse of the original table of values. Again, so in my original x values or my domain, I have here 1, 3, 5, and 7, and that is located here in my x, or in my x variable, or my input. So for the inverse, this 1, 3, 5, 7 will be written in the y variable. So in this inverse table of values, this is our y variables. That meaning 1, 3, 5, and 7 will be written here. 1, 3, 5, and 7. And also, the variable here in a in the y variable, or in the f of x, or our dependent variable 2, 4, 6, and 8 will be written as our independent variable this time. So this is now 2, 4, 6, and 8. That's how inverse of the function works. The original role will be interchanged when we get the inverse of the function. So now this is how the table of values inverse of the function works, ladies and gentlemen. The interchange of roles. Okay, so that's how the table of values works. But how about in mapping? Okay, so mapping is another way of representing representing a function, ladies and gentlemen. We believe that in mapping, same with the table of values, 1 here corresponds to 2, 3 here corresponds to 4, 5 here corresponds to 6, and 7 here corresponds to 8. And we believe in this correspondence of mapping, we have here at the center that is considered to be our function that processes your x variable in becoming, or in having, the outcome of y variable, ladies and gentlemen. But how the inverse function works? So the inverse function works here is we will be going back from where we started. Okay, so from 1 corresponds to 2, it will become we will now treat here, we will now having another treatment here as 2 corresponds to 1, 4 corresponds to 3, 6 corresponds to 5, and 8 corresponds to 7, going back from where it started. And from that, we will be having the inverse of the function. Again, do not forget to write, do not forget to write -1 as a indicator that we are referring to our inverse of the function. We are going to go back from where we started. That's how we treat the inverse of the function. To write it here as another mapping, we can have this one as x, and this is our f of -1 of x. Again, we have a function at the center that processes this one. So interchange. What is our new x now? All the numbers, or all our outputs earlier. So we have 2, 4, 6, and 8. So for our y now will be the independent, our input in the original mappings, which is 1, 3, 5, and 7. So from that, this is now the inverse when it comes to mapping. 2 corresponds to 1, 4 corresponds to 3, 6 corresponds to 5, and 8 corresponds to 7. So that is now the inverse of the function in this mapping, in this representation of function, which is called mapping. Okay, so that's how we treat that one, ladies and gentlemen. Okay, so that is the second. So now, without further ado, let's proceed to the third one, or to the to this what they call a representation of function, the set of ordered pairs. Okay, we believe the set of ordered pairs are used in graphing. Later that we will do it. Okay, so set of ordered pair, we believe that we have two variables, x and y, the first, or the domain, and the range. Okay, so what are the domain? Okay, what are the domain of this set of ordered pairs? We have 1, 3, 5, and 7. These are our domain, or these are our x. What are our range in this set of ordered pair, ladies and gentlemen? So we have 2, 4, 2, 4, 6, and 6 and 8. Okay, so those are the domain and range. So same thing, interchange the position, interchange the role in order for us to find the inverse of this set of ordered pairs. Okay, let's do it. So now, since this is my original set of ordered pair, I can write s raised to the power of negative 1, indicating that I am referring to the inverse of this set of ordered pairs. Okay, so let's do it. So s raised to negative 1. So my new inverse of this set of ordered pairs now are 2, 1, 4, 3, 6, 5, and 8, 7. Okay, so this is now the inverse of the set of ordered pairs. So that's how you find its inverse. Okay, again, same thing with mapping, same thing with table of values. Just interchange the position for you to find out the inverse of the original function, ladies and gentlemen. Interchange the position. If this is now if this is now the inverse of my function, what do you think are my domain here? My domain now here are different, which is the range in the original function, which are 2, 4, 6, and 8. And for the range, these are 1, 3, 5, and 7. Okay, so that's how we treat this the inverse of the function with respect to the representation of the function called set of ordered pairs. Okay, that's how we do it, ladies and gentlemen. Okay, so now last one is the graphing. Graphing is another representation of function. Okay, so as you can observe, ladies and gentlemen, all of this representation from table of values, mapping, set of ordered pairs, they are the same. And once you graph this one, it is represented as this graph. Okay, so now, how are you going to know if this certain graph has an inverse or it doesn't have an inverse? Okay, again, how are you going to know this certain graph has an inverse or it doesn't has an inverse? Okay, so these are how are you going to do? We are going to use some tests. Okay, we are going to use some tests that will really test this certain graph, or will test your certain graph if the graph contains an inverse or it doesn't have an inverse. So this test is what you call the horizontal line test. The horizontal line test. Okay, so the horizontal line test. If you still remember in my previous class, we used the vertical line test to test if the graph is a function or not a function. That is the vertical line test. But in horizontal line test, this will test your certain graph if it has inverse or it doesn't have an inverse. Okay, so how are you going to use this? Since this is an horizontal line test, so we will be drawing a line or a horizontal line in a certain graph. So let's try to do it. So I'm gonna draw an horizontal line. How many times it touches the graph? So if the certain graph touches the horizontal line once, it means that graph has an inverse. Okay, again, if the horizontal line that you draw only touches once in the certain graph, it means that that graph has an inverse. Okay, so another one, I'm gonna draw here. Again, it touches once. I'm gonna draw another one, it touches once. If I'm gonna draw horizontal line test infinitely, that horizontal line test will only touch the graph at once. And if it touches at once, meaning that certain graph has an inverse. Okay, so what are the example of graph that has no inverse? Okay, so I'm gonna draw another line, a graph here. Example, this one. Okay, I have here a parabola opening upward. If I'm gonna draw a horizontal line test, as you can observe, it touches twice. Okay, so since it touches more than once, it means that this certain graph presented here has no inverse. Okay, it has no inverse, ladies and gentlemen. So that's how are you going to identify if the certain graph has an inverse or don't have or doesn't have an inverse, using the horizontal line test, ladies and gentlemen. That's how are you going to do it. I do hope that you will remember how the this following representation be identified if it has an inverse or it doesn't have an inverse, ladies and gentlemen. Okay, using an horizontal line test. Again, if the horizontal line test touches more than once in a certain graph, meaning that graph doesn't have an inverse. If it only touches only once in every horizontal line test, it means that graph has an inverse. Okay, so that's how are you going to represent this all. Okay, these are the different representation of the function from wherein we integrate the representation of inverse of the function, ladies and gentlemen. Okay, so these are the things that we have to remember, and as you can observe, all the examples that I presented are the same, and these examples that I presented to you are an example of 1-to-1 function. Okay, if you still remember that we have different types of relations. Okay, we have one to many, many to one, a many to many function. But in inverse function, you can only you can only said that that particular function has an inverse function if and only if that function is a one-to-one function. Okay, so if that function is not one-to-one function, automatically that function doesn't have an inverse. Okay, so again, inverse function always associated with one-to-one relation. Okay, so if that function is one-to-one, automatically that function has an inverse function. Otherwise, you don't have an inverse for that particular function, ladies and gentlemen. Okay, so these are the definition, or these are the things that we have to remember every time we deal inverse of the function. Again, in summary, when we talk about inverse, it is simply the interchanging of roles between x and y. Okay, if the definition of the function is x corresponds to y, this time, inverse of the function is y corresponds to x. The roles are different, but we are still dealing with the same function. We are just getting its inverse, thinking it differently. Okay, so that's how inverse of the function works, ladies and gentlemen. I do hope that this video helps you on how are you going to define, on how are you going to represent function and the inverse of the function. Okay, so for more understanding about the video, about the inverse function, so you may proceed now to my next video. Again, this is Sir Robin Sanipulan. If this video helps you, do not forget to click the subscribe button and give me a thumbs up. Thank you so much, and see you in my next video. Bye bye.